In this lesson today, we're going to begin talking about quadratics. Up to this point in the year, we've focused our attention on linear functions, which create lines on the coordinate plane. Now we're going to be starting to talk about curves, or curves that are better known as parabolas. And before we start graphing these and looking at all the features of what makes up a graph, we have to know what the standard form of the equation is. In linear equations, we were given y equals mx plus b as our standard form of the equation. But with a quadratic, we're given y equals ax squared plus bx plus c, where a and b are coefficients and c is a constant. So a couple of features about a quadratic. If we look here below, you'll see that we have a parabola that's facing upward or facing downward. That part of the parabola is based off of the a coefficient of our function in standard form. If you look at the first graph here on the left, you can see that it's facing upward. That means that our a is positive. And when we have an a that's positive, we have something called a minimum point, which is a low point on the graph, as you can see here by the star. And likewise, when we have the parabola facing downward, we have a maximum point, meaning that it has a high point on the graph. Both of those 2 points are called vertexes. And basically what it is just a coordinate on the graph. And you can see also that we have this dotted line that splits both of our parabolas in half down here at the bottom. This is called our axis of symmetry. We know that symmetry is something that divides something perfectly in half, and that's exactly what this line does. It splits the parabola in half. It is an equation. If you remember back when we studied just linear functions, we talked about anything with the equation x equals will have a vertical line. And so the axis of symmetry will always be an equation that starts with x equals. It could be something like x equals 4, or it could be like x equals -8. We'll see a couple examples of this as we proceed. Okay, let's go ahead and start graphing. Pull out your graphing calculator because we're going to go ahead and we're going to be using that in this lesson here. Okay, here's our first function. And the first thing I like to do is label what my a, b, and c coefficients and constants represent given the function. So you can see that in our function here, we're given that a is the one that stands before the x squared. We're given -1. And the b is the coefficient that stands in front of the x, and that's going to be -8. And our c is our constant, so it's the number that stands alone. That's going to be -15. All right, now that I have my letters lined up, I'm going to start graphing by determining the axis of symmetry. This is the line that cuts the parabola in half. The axis of symmetry has a very special formula. This formula will actually calculate that axis of symmetry for you. So let's go ahead and take our a, b, and c and plug it into the formula x equals -b over 2a. So I'm going to say x is equal to -b. Well, you can see that our b is negative. So negative is actually part of our formula, and then we're going to put in our number that is going to be substituted in for b, which is -8. You can see what that does. It's actually going to create a positive. I'm going to divide that by 2 over a, which is -1. Once I plug that all in, I'm going to go ahead and simplify it. So I'm going to have 8 over -2. And I'm going to continue simplifying that to give me -4. Okay, my axis of symmetry is not -4. It's x equals -4. So I'm going to go ahead and write that down. And what I'm going to do is I'm going to go ahead and I'm going to represent my axis of symmetry using a dotted line. So again, anything that's x equals will be a vertical line. So I have a vertical line right on, hopefully you can see that, -4. And I'm going to go all the way up to the top. All right, that is going to be the line that splits my parabola in half. Next, what I'm going to do is step 2 here. I'm going to determine the coordinate of the vertex. Well, the vertex is actually going to be on that axis of symmetry, so it's going to have an x value of -4. All we want to do is figure out that y value. So to figure out the y value, there are 2 things we're going to do. And I'm going to show you one way, and then I'm going to show you another way. So the first way, what we're going to do is take that x value, and we're going to simply substitute it into the original equation that we were given. So I'm going to say that y is equal to -4 squared minus 8 times -4 minus 15. And you can see that I put our x value in parentheses, and that's really, really, really important. So be really careful. And then you can just go ahead and simplify. So I'm going to say y equals negative 16, right? Because negative 4 squared is 16 with a negative out front. And then I'm going to say plus 32 minus 15. And at this point, I would just go ahead and pop it right into your calculator, and I'm going to get that y is equal to 1. So since I got that y equal to 1, that gives me my vertex. So I'm going to go take that 1, and I'm going to go place it in my vertex coordinate. So this right here is the vertex of my parabola. So let's go ahead and plot it. Negative 4 and positive 1. There's the vertex. Okay. Now, another thing that, actually I want to answer one more question here before we move on, because we can actually determine this before we start graphing it in full. I want to determine the vertex. Is it a minimum or is it a maximum? Again, like I said, we could look at that A coefficient and we could determine if this is going to be a min or max. So since it's negative, this parabola is going to be facing downward, which means that we're going to have a maximum point. Now, let's go ahead and prove that. Let's go ahead into our calculators and press y equals. I'm going to go ahead and take a second and put my quadratic function that I have up top right in my y equals function. So I'm going to write negative x squared minus 8x minus 15. Be really careful not to use, for this, this operation right here and this operation, don't use the negative button. The front one is fine, you want to use a negative, but the other ones are going to be minus signs. All right, once it's in there, go ahead and press graph, and the graph will actually show you what it's going to look like. But we don't want to just take it off the calculator and plot it down. We actually want to put some time into this. And what we want to do is we want to go ahead and find those points. So let's go ahead and go to our table of values. Press second graph. This will give you all of the points that are going to be on this parabola. So let's go ahead and find our vertex. You can find your vertex right on the calculator, negative 4, 1. So that means that that's going to be the center point of our parabola. So instead of using all the points, let's just use a couple of points above the vertex and a couple of points below the vertex. I'm going to go ahead and I'm going to start with negative 7, negative 8. I think that's a good one to start with. So I'm going to go negative 7, and then I'm going to go down negative 8. And I'm going to go right here. Once I plot this point, I can actually reflect it over my axis of symmetry. And so I'm going to count how many spaces away I am from the axis of symmetry. 1, 2, 3, and then I'm going to count how many spaces going in the other direction, the same amount. 1, 2, 3. I'm going to go ahead and plot that point. All right, so now I have 2 points, and you'll actually find that other point in your calculator in just a little while. So let's go ahead and choose another one. How about negative 6, negative 3? So negative 6, negative 3 is right about there. And I'm going to go ahead and reflect him over. Perfect. And I think I have one more I want to put on here. I want to put negative 5, 0. So negative 5, 0 is right about there, right on my x-axis. And then I'm going to reflect him over. Now you can see that these are all the coordinates that are going to be represented on our coordinate plane. Any others are going to actually go off the coordinate plane, so we don't have to represent those. At this point, now that you've represented all those coordinates, I'm going to go ahead and I'm going to connect my dots and make a nice parabola or a nice curve. And at the ends of my parabola, I'm going to have little arrows, just like we did in our linear functions unit. And that means that this graph is going to continue on and on forever, which is why you see all those points in your graphing calculator. These two arrows will go on and extend in that direction forever. Okay, so we've actually done step 3. We determined other points of the functions using the table of values. That's great. Now, step 4. Let's go ahead and review something we did way back in Unit 3. Let's talk about the domain and range. If you remember back in Unit 3, the domain value is all of the points on this particular graph that have an x-coordinate. And if you remember way back when, we talked about this, signification here called set notation. And we always represented a parabola like this, x such that x exists in the reals. Because anytime you have a parabola like this, it'll always have an x value. And then the y value was the one that was a little bit more complicated. The range values would be y such that we have to look at that high point or low point on our parabola. and we see where he is connected to the y-axis. That's going to be our range. So our range is going to be everything that's below 1. So we're going to say y is less than or equal to 1. And that's how you graph a parabola. Let's go ahead and try a couple more. Alrighty. So in this next one, you can see that we have a coefficient of 2 as our a this time, which is a little bit different than the last one. So let's go ahead and find our a, b, and c. We just said that a is 2, and b is going to be negative 12, and c is going to be 16. Let's go ahead and find our axis of symmetry first. All right, x is equal to negative b, so that's negative 12, divided by 2 times our a, which is 2. It's usually pretty simple math, so let's go ahead and calculate it. So we have positive 12 over 4, which simplifies to 3. So our axis of symmetry is going to be x is equal to 3. Remember, an axis of symmetry is an equation. It's not just a number. All right, let's go ahead and graph it. It's a vertical line on 3, so I'm just going to go ahead and put a dotted line on 3. There we go. Step 2, determine the coordinates of the vertex. Now, I told you I was going to show you one way and then another way. The first way that we did was by hand. So the second way is the way that I actually would kind of recommend for you. I go and use the graphing calculator. So let's go ahead into our graphing calculator again, and let's go to the function y equals. Let's go ahead and put this quadratic function in. 2x squared minus 12x plus 16. And let's go ahead and graph it to see what it looks like. And let's actually go straight now to our table of values, second graph. I'm going to look for the y value that is corresponding to that x value that we just calculated. So if my x value is 3, my y value is going to be negative 2. So I really don't even need to show any work for this one, which is kind of nice. Now, if I want to determine my vertex, if it's a minimum or maximum, again, I have to look at that a coefficient. This time it's positive, which means that it's going to be facing upward. If it's facing upward, it's going to have a minimum point. And we'll see that in just a few minutes once we graph it. Okay, now that we have our vertex, let's go ahead and graph that on our coordinate plane. So I have 3, negative 2. Put a nice dot there. And now I'm going to go back into my table of values and I'm going to plot some points. So let's go find some. Let's find the first one. Let's do 2, 0. 2, 0 is a coordinate. And I'm going to reflect it over that axis of symmetry and plot my other coordinate. All right, now I'm going to choose 1, 6. That looks like a good one. And again, I'm going to go ahead and reflect him over. And let's see if we have any others. Looks like the next one in line is 0, 16, which is way off of our coordinate plane. So this is actually going to be the last point that we put on our parabola. So I'm going to go ahead and draw my nice graph. And your nice arrows. Very good. Alrighty. That was step 3. And the last step is determining our domain and range. So here we go. Our domain is going to be x such that x exists in the reals. It's always going to be that. At least for right now while the parabolas are facing upwards or downwards. And the range is going to be y such that we need to locate our low point. So our low point is actually going to be when y is negative 2. So we're going to say everything that's greater than or equal to that negative 2. That's our range. And we're done. Okay, I have a couple more here for you. Actually, I think I have one more for you. Let's take a look at this first one. All right, this one is slightly different because you can see that not only do I have a coefficient a that is a half, a fraction, but I'm also missing a b. So whenever we write down our ABC, my a will of course be 1/2, but my b will end up being 0. And of course I do have my constant c of 1. I'm still going to solve it as is because we still know that this is a quadratic because it's a polynomial with a degree of 2. The only difference is between this one and the last one is that now we have a binomial of degree 2 versus a trinomial of degree 2. Okay, let's go ahead and solve for our axis of symmetry. X is equal to negative b, which is 0, divided by 2 times 1/2. So I'm going to go ahead and simplify that. 0 divided by 1, and we know that's going to equal 0. So my axis of symmetry is going to be x is equal to 0. Now on our coordinate plane, that's just going to actually end up being the y-axis. So you can see me highlighting that right now. And I want to move on and find my vertex. So my vertex is going to be x as my, 0 as my x coordinate. Let me go ahead and erase that. Okay, 0 as my x coordinate, and then I have to go find my y coordinate. I'm going to do that right in the graphing calculator. I'm going to go ahead into my y equals, and I'm going to go ahead and type in my function, 1/2 x squared plus 1. And I'm going to press second graph to grab my table. And I see that 0 corresponds to the y coordinate 1. So that's going to be my vertex. Now, if I want to answer the question, is that vertex a min or a max? I can just simply look at my a value, and I see that it's a positive number. So that means my graph is going to be facing upward, which is going to give me another minimum. Alrighty, so 0, 1 is going to be my vertex. And let's go grab some more points. All right, you can see in your graphing calculator that this time around, since you have that fraction as your a coefficient, you have some decimals to work with. Try to work with as many whole or integer numbers as you possibly can. So I'm first going to start with, I don't know, let's say -4, 9 looks pretty good. Let's look at -4, 9. Go ahead and plot that. -4 and 9. And I'm going to go ahead and reflect him over. 1, 2, 3, 4, 1, 2, 3, 4. There we go. Okay, let's go ahead and choose another one. Let's choose -2, 3. -2, positive 3, and I'm going to reflect him over. Great. Okay, at this point, all that's left are decimals, and you are more than welcome to use some decimals, but I'm going to go ahead and leave those out for now. And I'm going to go ahead and graph it. So I'm going to draw a nice parabola with my arrows at the end. There we go. All right, so we've completed step 3. Now let's take a look at step 4, determine the domain and range. All right, I'm going to say that x such that x exists in the reals. And I'm going to say that y such that, let's go find my minimum y value. You can see that it's actually on the y-axis and it's going to be 1. So it'll be everything y is greater than or equal to that 1 number. All righty, and that's how you graph a quadratic function. Now, there's one more thing I want to kind of introduce to you. If we look back at these 3 graphs, you can see if you look at the first graph, if you look at the third graph, the one that we just did, and you look at the previous graph that we just graphed, you're probably wondering, well, why is one narrower and why is one wider? Well, it all has to do with that coefficient a. If that coefficient a is an integer number, and it continues to get bigger, that means that it's going to become thinner. Versus if you have one like the last one we did with a fraction, as the number gets smaller or becomes more of a fraction, it's going to continue to get wider. So it's kind of an interesting little characteristic about our quadratics. So always keep that in mind as we're working through these. So that's the end of our lesson on graphing, and we're going to continue through the unit and we'll be using this skill as we go.